and welcome to another episode of AI Buzz. Thanks so much for tuning in today. Some really cool things coming up in this episode, so stay tuned for that. I want to make a quick announcement about a new service that I'm launching, and this really stems out of a love for helping people learn how to code and grow their skills. The service is going to be a one-on-one Python tutoring session. If you're interested at all in that, email me at the email in the description for more information. Enough of that. In this video, we are going to talk about the 5 steps that I would take if I was rewinding back to before I had ever even touched a cloud machine learning platform or a cloud platform in general, and how I would start learning those platforms, and even better, how to maybe do machine learning on them if I was starting today. My path was a lot more circuitous than the path I'm going to lay out here. So essentially you're getting a distillation and a summary of all my learnings and mistakes and pain and suffering. If I was starting today and wanted to learn cloud platforms and how to create scalable machine learning models, I would start growing my horizons beyond Python. When I was first starting to do a lot of data projects, I was obsessed with Python. I had to use Python for everything, and I still think it's an incredibly good language. However, in the real world, when you're dealing with a real company's data sets, when they collect terabytes or tens of terabytes of data, Python is likely not going to be your language of choice. You're going to need a way to really transform and load and do meaningful feature engineering on all this data, which can definitely be tens of billions of rows. In order to do that, you're going to have to start using a distributed computing framework. So one of the most popular ones is going to be Spark. One piece of advice that I would give you if you want to pick up a language like Spark, a lot of these have wrappers around them. So like for Spark, if you really like Python, what I do a lot is I'll use PySpark. So a lot of stuff will look familiar if you're used to writing Python. Some stuff will of course be different, but it helps bridge that gap between what you know and what you don't know. PySpark's going to be a lot more approachable than trying to learn something entirely new like Scala. Step number 2, I would say try to find a cluster infrastructure that's going to allow you to deploy Hadoop. You can run Hadoop and Spark on your local computer. Nothing requires these languages to run on a computing cluster. However, you're not going to be getting any sort of speed advantage since you're just going to be running it on one machine. If you really take the time in step number 1 to learn about Spark, how it works, and that you can split up a lot of these jobs into highly parallelized segments, you'll understand the power of a cluster, because then you're really going to benefit from having more machines and more compute online. My favorite choice for this infrastructure so far has been the Amazon EMR, or Elastic MapReduce. The EMR consists of a master node as well as core and task nodes that you can use the master node to kind of delegate and plan work for these other nodes to tackle. That brings us to step number 3, which is learn by doing. And learning Spark by reading is going to be just about impossible because, number 1, there's not a whole lot of great materials out there on Spark that teach you step by step how to do it. And number 2, it's always best, in my opinion, to pick a project and really, involve yourself in it and learn through actually putting it into practice. For this step, which is learn by doing, I would say try to take one of the machine learning projects that you have running locally, say a random forest model, and try to get this running up in the cloud somewhere. You're going to notice a lot of things actually have to change as soon as you start shifting from smaller scale to larger scale. For example, if you're using sklearn, well, that's not going to be extremely scalable, meaning that you can't really run it on multiple compute nodes. You'll find that PySpark has a lot of built-in modules like random forest regressors or classifiers, and these are going to really take the place of a lot of the classic sklearn functions. The syntax is going to be a little bit different, but they're optimized to run on this distributed computing framework. Sure, you can just plop your Python code up in the cloud and have it run, but this is going to be essentially the same as running it on your local. There's no distributed computing framework present. The main benefit of the cloud is going to be scalability. So getting a lot of machines to crank through that same code on smaller segments. Step number 4, I would say, is try to implement something that is production ready. Machine learning in the cloud is really going to set you apart from others when you go for an interview. There is absolutely a big clustering between people who have done a lot of cloud-based machine learning and those who haven't. My experience is really similar to you need a job to get a job. except it was more along the lines of you need cloud computing experience to get cloud computing experience. I remember I had one interview which was for my second job. I had a lot of programming experience at that point, a lot of data analytics experience, had my advanced degree, which set me apart. So I felt really qualified, but they asked point blank if I had any EMR experience. And despite all that other stuff, it's almost like they didn't care. They knew the learning curve in the cloud was going to be steep, and they probably didn't want to train me up for that. Companies really want people who are able to hit the ground running with cloud technologies. Right now, a lot of companies would way rather have a model that can be scaled and deployed into production rather than a machine learning algorithm that you can run locally and maybe it gets great results, but you're not able to run a massive amount of data through it. In the company's eyes, what good is a model if it can't be scaled to terabytes of data? They're willing to accept less accuracy if that means gaining visibility and insight into something that was previously not visible at all. And last up, I would say for step 5, if you're in the EMR or you're in the Google equivalent, learn how to monitor that system too, because it's very easy for these things to just crank through jobs. If you're able to really understand the monitoring behind it, that's also really going to set you apart. AWS does a really good job of allowing you to do this right from their console. You can see how many nodes are up, the health of those nodes, the amount of resources, CPU and memory that they're using, etc. There are a bunch of other integrations you can use too for monitoring. One of those is called Ganglia. You're going to install this when you spin up your EMR cluster, and that's going to give you a lot of nice looking graphs to troubleshoot issues. So to wrap up today, I would start learning cloud computing and trying to do machine learning in the cloud by doing these 5 steps, and those are: start expanding your horizons beyond Python. Push a local machine learning project to the cloud and try to understand how to make it scale. Try to make it run twice as fast as it previously did. Also, really learn how to monitor the cluster and the execution time of your jobs. That's about all I have for you today. If you enjoyed the video, give it a like, as well as the channel a subscription. Have a good day. Bye.